How's it going, everyone? Ariel Gonzalez here again, looking at the React Performance course taught by Steve Kinney, the head front engineer at Temporal, this open source tool that is a durable execution platform. You can pretty much think of that like Kubernetes to cover some specific business use case. So, for example, like Vercel, when you're able to now deploy any front-end application, okay, and host them into their service, so they can. That's a pretty interesting tool, by the way. So, in today's video, the entire reason of this is to look at now this section of the learn topic from React of passing data deeply with context, and then how we can scaling up with reducer and context as a way to now move on to the next topic, which is escape hatches. All right. So being able to describe each one of them as a way to have now this mental model when we need to write or when we're going to design our React components, and therefore our React apps. Okay, so for that, I'm just going to make a quick recap of this, where now the goal here is of this course is to see how can we now write performance React components, and there's several topics here. So, for example, this course structure is in the introduction, React rendering, reducing rendering, context, suspense, and transitions. I'm gonna briefly describe this and then finally jump into what we care about in today's video. So this introduction is as a way to say, okay, who is this course for? Well, to anyone who need to know how React works. Eventually you will need to know how that works, and eventually you will need to know how the JavaScript works, and also now how the computer science or the computer works. So it is this particularly reverse engineering that you can start with, and I think this might be one way to learn this. The other is that from the ground up, which means is that from the computer until React. But again, most of the time you have to decide which learning process works for you. Is reverse engineering, or is actually looking at the history to see how do we get here, because that way is how we make sense of the work. So if you want to now look at how React works, this course is for you, as well as how can we now develop a tool set that allows us to identify this React performance issue. So when that happens, we come up some best practice solutions for that. This is pretty much like untying a big knot. When you're starting to pull the right threads with the technique that you already know over and over and over and over, then you solve that. So the value proposition of performance in the React context is that it is faster to not doing things than doing it. And there's some color that is to that. So it is faster to do things later than doing it now. So the idea here is that something that you can apply also to your life as a way to prioritize tasks. Hey, is this actually things that is this a priority in your life? No? Why will you even consider to think about it? But in any case, that actually works. And this is the React performance value proposition. Okay, so when we look at what are the tool set that we're going to apply, or all of this checkbox that you're going to apply when you have a performance issue is that first, take a look at the bundle in React production. Hey, are you using the development or the production? Okay. Second, take a look at now the React component hierarchy, and it is a state to start from them. The other is that, okay, what is the catching strategy, or therefore what is the memoizing strategy that these applications follow? Look at how now they are loading components later on using the suspend API if they're using it, and how you can leverage that. And lastly but not least, if you're in a pickle, well, see how you can use transition for that, which is this way of looking at low priority rendering. So that's great, that's interesting, because now we are going to see is the React rendering and how that works as a way to make this smooth and quickly possible. So after all, React is a JavaScript framework that allows us to describe UI. And the way we can do that is by using JavaScript functions. So those JavaScript functions has now a particular way, or return something particular, okay, which is now this HTML tags. Okay, we also look at how can we import this component, how can we export those components, what is this syntax that allows to return this HTML or tags, aka GSX, and how that allows to connect our JavaScript to the HTML. Also, we look at how can we create conditional components, or rendering conditional rendering, as well as rendering a list of elements, and how important is the key as a way to notify React, hey, I want you to now keep track of this state. I want you to now have like a table, and anytime you find a key for that, hey, you want to store this. And when something's changed for that, I would like you to now reset the state of this, okay? Something that we're gonna see how that works. And we also look at the importance of how do we need to write our React components, remember, JavaScript functions, in a pure way, because that allows us to run that function in any JavaScript environment, whether it's the browser, the server, or the workers, as well as looking at how can we now catching this function or these React components, perhaps using memoization techniques, okay, as a way to save computational time. And lastly but not least, how can we pass down data, and when we need to stop that, or when React needs to stop that, it can do that in a safety way. So with that, we talk about is now passing this data and that kind of thing. It's like the way how now React see this component is by using a tree data structure, which comes from the computer science, which is a way of how you organize your data. And when you organize your data, this is pretty much like having different devices that are good at storing and retrieving stuff. For example, you have your fridge, you have your backpack, and your backpack you can put is your pencils, tablet, iPhone, and also you have your fridge when you can put your ice creams or any food that you want to preserve. For example, fish. You can put fish in your backpack. There's nothing wrong with that. But that's not the best place to actually store that, if you want to store that, okay? And this is now the data structure. This data structure actually provides you a particular way, or give you now a a way of how you can now interact with the data, how you can store the data, as a way to retrieve that in the most fast way possible, which is in a constant time, a big notation, which this is a function. What it measures is that no matter how many elements do we have, all right? For example, no matter how many fish do you have in your fridge, okay, you will be able to always get the fish that you want, all right? So no matter how many pencils you have in your backpack, you're able to get the pencil that you want, okay? No matter the color, you're always able to get that no matter where they are. So this is something interesting, because now coming back here, there's several data structures like arrays or hash. Hash, you can think of this like a table, okay? You have the key, the value. We also have is stacks as a way to now put all of this data on top of it. We also have queues, which is something that the JavaScript engine actually use that, as well as Node, as a way to add all of this callback function. It doesn't matter if you don't get what I mentioned. We also have another data structure like linked list. What allows is to navigate, okay, in the browser. Hey, I would like to navigate to this next reference or the previous web page. So all of this, particularly data structure that I mentioned, is something beautiful, and now provide us is a way to organize our data. So tree is one of them, graph is another one. In the case of tree, it's like this now is the way how React sees our components, and that allows us to look at not only how that is organized, but also the text and performance issue, as well as understanding how the data flow goes through that. And we also have the tree dependence, that is this utility function that we pass to our React components as a way to reuse them. So the more lightweight these functions are, or these utility functions are, the better off. Because otherwise, if you have uploaded code in your React components, that'll be sent that to the client, and if there are on poor coverage areas, that actually is a concern. So with that, we know that that the React component, the render tree and the tree dependency exist, and what they mean to, what they offer. Now we look at how can we now add interactivity, because so far we look at how can we describe the UI. So adding this interactivity through the event handlers, okay, and also how can we now show data to our components using states, which is a component's memory. So by using a state with use state, and how can we set that state inside of our handlers, we are able to now update the state here. But also we are now behind the scenes triggering is a mechanism, a rendering mechanism, which is something that comes from React. And it is made of 3 stages. So you got the trigger that actually detect when that happened. So it can be the initial component or the initial render, or a component that state updates, or any of its ancestor. So when React detect that, it say, all right, now depending of when that happens, I'm going to render this, which is I'm going to call these components. If that happened at the root render, all right, now what I'm going to do is to create these elements here. And they use is the create elements from the document. And however, if that happened at the render or it happened as a re-renders, okay, meaning that if that state update triggers, if that state update was at the component level, well, now React will call that component, and the output, which is a GSX, it will hold, it will evaluate and say, hey, do we have is another React component inside of this output? Yes, let me do that in a recursive way. In other words, I'm going to call those components, and the output, which is a CSX, I will continuously call that, so on and so forth. So anytime now JavaScript is, in this case, React is rendering, meaning is calculating, is calling your components, it also compute all of its properties from that event handlers, props, and state, and it store that information to be used in the next stage, which is the commit. So now once the React pass through all of these components, all right, and reach to the end, and reach the end of the tree, it is time for them to say, okay, when this component happen, okay, or when this state update happen, is this was on the root render, okay, is the initial entry point. All right, so let me now there append all of these elements to the DOM. It also uses the append DOM API. It append all of this, right? This is the initial render. However, if that was caused at a component, if a component caused this state updates, then what it's going to do is to look at the previous data that he stored and compare them, and if they are different, then he will apply the necessary DOM updates for that. You may wonder how it does apply these necessary DOM updates. The docs doesn't describe that. That might be go beyond the scope of the work in this course, but it's important to understand that this is what React does, and you're able to describe that. Okay. So once React now, once there are different between renderings, now React apply the necessary DOM updates to that. And finally, the browser detects those DOM updates and say, all right, so let me now repaint this. So this is the entire process of what is happening behind the scenes. And I think that's quite interesting. It's like, it's a beautiful mechanism. Because this is what allowed to build, to write here. We also look at what's going on when we set the state, okay? Not only for the rendering perspective, but also is that for working with the state. So you can think of this state as a snapshot. So inside of your handlers or your event handlers, you're going to the variable state updates happen is in the next render. And when you are working with your states, when you're setting your state inside of the event handlers, React will fix that state value within the render's event handler. So this something is interesting and important to know, because this set the foundations for what's coming next. And that is, well, how can we now queuing a series of state updates? So we can pass this an arrow function to set our states. And now, how can we, for example, and now how can we, for example, when do we need actually to use, or when we need to enqueue those state updates, you may wonder. For example, if you want to perform several series of state updates, trigger a rendering, and then perform some async operations, okay, inside of your event handlers. If you want to do this, there are some other alternatives to actually do that. So for example, like this, using is effect and that kind of thing. Something that we're gonna talk that later. But again, we were only talking about is how can we now queuing a series of state updates. Also, we look at how can we update objects in states, as well as array states. A TLDR always return a new state, period. If you want to have a consistent way to do that, use immer, that it provides you a mutable syntax for that. And when it comes now to manage our state, which is something important and crucial here, is that first we're going to look at how can we now give state, how can we provide a state structure, how can we make our state update logic maintainable, and also how can we pass down data to distant components. So first is reacted to input with states, and here we're now taking borrowed concept from, so we borrow the concept from the UI designers, where the mental model of we're gonna use as a way to describe our components or reacting to inputs with states is pretty much like the UI designer does, which is visualize all the different states, identify what trigger those state updates, whether it is computer or human inputs, okay? And then represent those states in memory with use states, so you can eliminate any non-essential states, and connect the handler to set the state updates. This particular process of reacting to input state is something important because this will lay out the foundation of what's coming next, something that I mentioned before, right? But understand now this mental model that React is giving to us as a way to now think in terms of how you're gonna recreate your React components. It provides us now this guidelines of that. So and this is something useful to think about because, for example, when we are going to now describe the states and how to manage our state, how to describe our state organization, or in other words, define the state structure here, is that now here with a borrowed concept from the database engineering, we're going to look at how can we now manage our data, manage our state. First, we look at how can we manage is our UI elements, okay, react to inputs with states, okay, and then we look at now the state management or state structure as a way to eliminate redundancy and duplicating. And this is a principle that React provide, like group related states together. One, avoid contradictory state, avoid duplicating state because they are hard to sync, avoid redundant state. By that is, hey, can I get this data from this props or from another state? As well as avoid any deeply nested object in a state. So when you're encountering is UI selection patterns, it is useful that you must rely on the ID or an index. An index or ID that must come from database. If you're not, use the UUID. Okay. So far, I think that everybody can understand this, okay? So you have now a particular way to react input with states. Therefore, is how can we now create these visual elements, and then how can we bind that to our state as a way to now trigger a rendering, okay? And also how can we now organize our state structure. So then we look at now how can we share states across the different components, share between different components. This is known as lifting a state up. Okay. Why this is important? Once I look at that, how you can lifting a state through that, okay, by saying, hey, all of these child components have all of these different you want to share a common state of all of these child components. So you create that you create a pattern components, okay, that now will first eliminate those state in those child components, hard code the data by now receiving is that data as props, not only the data but also is the handler, okay, and then in the pattern class is when you're going to define that state. So why this is important to describe? Because when you're going to design your components or describe what is the capability that this component has, it is important to think of that in terms of uncontrolled and controlled components. This is not a technical term, okay, or this is not a wildly technical term, but this is what React mentioned anytime when you want to know how you're going to design this component and what are the capabilities that it offers. So uncontrolled components are components that are state driven, where now control components are components that are props driven. So with this particular use case is, well, now the uncontrolled components, usually you can use that to set some sort of configurations. And now your control component as a way to receive that configuration, and they're much more flexible than that. So this is some sort of orchestration that is happening here. And when you put a piece of code, okay, when you put a piece of code in your component, or for each unique state, you will choose which components owns it. And I think this is something interesting, very, very interesting. Why is that? Because now we can have is not only terminology, but also a more clarity about when we're going to write all of these components, on how we're going to design this component, what will be the capability of these components. And I think that's quite interesting and more and clear. Yeah, totally. So then we look now at how can we is to reset or preserve the state in our components, because a state is tied to the position at the render tree. Therefore, if you have the same component at the same position, it will preserve its states. However, if you have different components at the same position, it will now reset the state. If you have or if you want to preserve the state of the same component at the same position, I mean, if you want to reset the state of the same component at the same position, now you do is or render the components in different position in the tree, or use a key for that as a way to know, as a way to notify to React, hey, I want you to make use of this for that. So that might be quite interesting. Oh, yeah, so that might be quite interesting as a way to solve that. As a way to solve that. Yep, that might be quite interesting as a way to solve that. So, all right. Now that we know that, all right, how can we reset and preserve the state? And also, how interesting is this as a way to now add the ability to build a chat here? Okay, hey, I want you to preserve the state, I want you to reset the states, I want you to also now, when you're rendering elements, preserve and reset the state. And also we look at what will happen when you want to extend, or what will happen when you now have multiple user in, when a state is handling multiple user interactions or multiple inputs, whether it's a computer or whether it's a computer, whether it's a computer or human inputs. So user interactions like clicking, drag and drop, like clicking, drag and drop, like clicking, drag and drop, and that kind of thing, right? Yeah, clicking, drop, copy, paste, when a state is handling multiple inputs, human inputs or computer inputs, hey, it's now reacting to a data that come from the server, okay, or waiting, or when you want to load an image here. So when that happens, you want to extract your state update logic into a reducer. Why is this? Because something that we look at this, so the more inputs this state is reacting to, the more verbose your code becomes. AKA, you have now all of these event handlers or function handlers that make your code long and verbose. So as a way to now make to keep the state update logic consistent, we use a reducer. Again, it's a particular way of how now how can we make the state update logic consistent, which is first get all of in your event handlers, replace the set state with dispatch. So now you're going to return, instead of a new object or an array, okay, you're going to return this now as a new you're going to now is return is a new object with the type there called action, and this action have a type which will be the type of actions or transformations that you want to apply. What is the type of state updates you want to apply based on the user interaction or this input, human or computer, followed by the data that you want to change, right, or want you to update. So then you look at now your reducer, you create your reducer function, which is just a fancy term for a function that it receives an state and an actions, and based on the action type, it will generate a new bit of a state. So what does it mean? That is, here is when you define using a switch case and looking at the action.type, hey, we're going to return is now this object to react always in a pure way, returning is a new state from that, as a way to update the state for that. And to notify React to do that, we use now a hook called useReducer. The first parameter that this function receives is the reducer functions. Okay, all of these actions that you can do, all of these inputs, all of these state updates that you can do, or all of these updates, all of these update types you can do to that state. All right. And then the second parameter is the initial state from this. So this is something interesting completely, because now what is the difference between the use state and the use reducer? And is that for simple user interactions, keep use state, because it actually makes your code less verbose. All right, it actually makes your code cleaner. You have a clean code, readable and clean code. But as your state have to manage multiple inputs, computer or human inputs, computer is network operations, they react or wait for this data to be low, or receive that data from the server, or wait for this data to, or wait for this image to be low. And for human interactions is listen to a click event, so reacting to an input or typing. So for that, the more states the more inputs this state have to handle, the more input states, the more inputs a state has to handle or update, the more state updates, or the more inputs a state has to react to. I would like to do that. So the more input I think I'm gonna write this. So the more inputs, whether it is human, exactly, the more human or computer, like so, the more input, human or computer, your state have to handle it. Okay, the more inputs, human or computer, your state has to handle, the more convenient or the more compelling a reducer function becomes. You know? And that's one of the value proposition of this reducer. So instead of actually us to write that in a reducer, okay, for example like this, so the more input we have, the more input we have, the more input a state needs to react, the more compelling reducers become. So for simple state updates, there's no need to actually use reducer, okay? And the way you write your reducer well is by making them pure. And when each action described is a single user interaction, even if that leads to multiple data in the multiple changes in data. So it makes more sense to dispatch one reset form rather than 5 separate set fields actions. But we also look at immer as a way to write consist reducer in a mutable state. Okay. And we also look at how can we now is not only implement our own reducer, which is quite interesting here, to implement our own reducer, because after all, this is a function, the dispatch function. It receives as an action, as an object, that will be passed down to the set state, followed by the reducer. That this reducer have is the state and the action for that. That's quite interesting. So anyway, and they call this reducer based on the function called reduce from an array, which what it does is to having a collection of elements, you're going to accumulate is the output based on some transformation you apply to each one of those elements. So that's interesting. Yeah, that's interesting. And also look at how can we exactly, it's like implement this kind of behavior. For example, like chat. Hey, I want you to now reset is this chat for that, or to preserve, in this case is this. I want you to now to preserve is the state of our chat. And by preserving that, we're going to preserve that is on an initial state by saying something like this. So if you want to preserve something, or to remember something, or to select something, which is here, we use the index that must come from the database. Okay, so anytime you want us to do a selections or to remembering a state and that kind of thing, it is important to now have an index for that. An index that you can or generate or ask for the database. Usually ask for the database. So in our example here, this is when we're going to store now is our message here. For example, hey, hello, Taylor. But all we're doing here, okay, is to say, in my state, I want you to now remember this. And anytime I select this, I want to show that. So here is when this describing is that, okay, when you hear that kind of thing, it's like, all right, good. When you select this, when you select this, okay, hey, I want to remember this when I select this. And this is pretty much what we're gonna do. I want to select this. I want to reset this. When I want to show this. I want to show this when I select this. Quickly say, if we talk about selection, it's highly likely that we need to use an index for that. It's a high chance that we need to use an index for that. Somewhere we need to use an index. Index that must come from the database. Okay. Index that must come from a database, or that we can self-generate that. Oh, makes sense. Anytime, okay, this is a way, again, this is the React way of doing this. Interesting. So things started to make a lot of sense. So for example, if I want to create now a drag and drop API, and if I want to select that, okay, I will now have an initial state that will store all of this data for that. And that initial state, okay. It makes a lot of sense. Yeah. Okay. 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 Holy moly. So, for example, when someone asks me, "Hey, how would you implement this?" Yeah, how would you implement is the let me see. Yeah, how would you implement is the drag and drop functionality. Okay. Yeah, how would you implement is the drag and drop functionality. Yeah, how you will implement is a Trello board like, okay, with all of the things that you already know. Well, because we want to have several columns here. So first we're going to make some. Here we're gonna make some mock here. We're gonna mock our this. We're gonna put our static components here as a way to show them. All right, put all of this static content. And then now things in terms of our states. Okay, how our states, how, yeah, how. So first is identify all the different visual states here, okay? And that is, you have all of this. So initially you have all of this for column with no elements. You can also have columns in, you can also have car in one of these columns, okay? Or multiple. You can have one car in this, you can have one car in the second column or multiple, and so on and so forth, right? So that's defining as a different visual state. We have an initial state, an empty state, and we have also a car state, okay? So now that we have them, then it is time to understand what triggered those state updates, okay? So, because after all, we want to have is now this drag and drop. What we care about is to have this drag and drop functionality here as a way to now get this element from the source of the draggable, the source element to the target element. Okay, there are several events here. So depend of how many events do we need to respond. Depend of how depend of how this state need depends of how inputs, in our case, user or event handlers, it needs depend on how event handlers this input needs to depend on how event handlers this state needs to respond. It'll be more sense to define the use states or go with a reducer. So now we take a look. Now we need to take a look at how many interaction we are responding. In the case of the drag and drop API, we have is the drag elements from the source and dropping in the target. We also have another event that is that's on drag, meaning that you're gonna show something as you drag that element, and the other is the drop some event, something like that. So now here it will make much more sense to starting to work in terms of reducer. By all of this, at least that I mentioned 3 relevant events here. Just to mention 3 relevant events. And also because we want us to now keep track of each one of these elements. We want to remember each one of these elements. We want to remember each one of those car inside of these elements. It makes much more sense to have now an state for that, an array for that column, an array of cards. Okay. So things slowly to have changed here. Here's slowly makes a lot of sense when you're going to develop that. So what we're doing here is that, all right, in the context of message, we're going to create a new state that will remember this thing, okay? And when we now want to change the selection, we're gonna get rid of this, okay? We're going, in fact, actually is on edit the message. We want is to now add a attach that to the proper. We want to attach that content to the proper data here, which is message the state.selectID to what we get here, to the action message here, followed by the whatever you have in the state.messages, because after all we want is to now attach these elements. So you say, hey, and now that we properly update the states, now it is time for us to, at the initial render, select that, which is here. You say, hey, let's go to now actually is go with the initial state dot message, or you can say is with the selected in initial state dot selected ID, and selected ID is this. It's out with 0, right? So this is it. Initial state. It's an object that contains this initial state. Plural message. Here. Oh, because this is an object, exactly. Not an expression, exactly. Hello, Taylor. So with this, interesting. Now it's showing that to all of that, but we don't want that. For some reason, it's not changing that. So we need to actually change that, okay? Which means that here, you're going to change that. Select ID is action.counter ID. So you're changing that. Yeah, you're selecting that. On the change selection here, we say, hey, state and selected ID is this. Action.counter ID, we are properly receiving that counter ID as a way to state select ID. Okay. So we're receiving is the state select ID. That's right. And then we dispatch this. And when we dispatch this in our app, you're gonna say, hey, who dispatched this? Which type of action you dispatch here on the contact list? So on the contact list, they dispatch the change selection. So change selection here was dispatched. In our reducer, change selection is this. Selected ID is properly updated. And then we're supposed to have is the proper selection ID here, which is here. All right, now we select that. We are going is to now show is data for each one of them. Say Alice. And say Bob. I think it's Bob. Okay. But here we are not is on change selection. We're gonna change that. And here we're gonna say is state.selected ID. Is now the action message for that. So we have to keep track of this. Oh my God! Is status now? Is a status selected? Is yes. Yeah, it's a status selected ID, but it is inside of the message. This is inside of the message. Okay, when you get is this. When you have is this. You get your message here, and I just want is to add that to the message. And I'm using is the state selected. Okay, it's preserving this state. It's preserving this state. State selected ID and state in action dot message. Okay, we're gonna append the message here, but it says that state here state dot selected ID, which is 0. Hey, I want you to not add this message and return this, which is quite interesting. Because here I want you not to spread all the message that you have there. Exactly. So I just want you to get me all of the message that you have here, and that match updated. No. Change selection. There's a way to select that. So far, so good. But when it comes to now edit that message, we want us to edit the proper message. Okay? Which means that we want to return is the new state from that. Are we getting is type message, correct? And here perhaps we are not picking up as we're supposed to, because it's the state.selected ID. Exactly. We haven't not the update state. We have is just that initial state. So anytime it's wrong, it say, hey, but this is 0. State.message and state.selected ID. So that what's happening here is that because anytime we're calling is this, and we are not updating that state, because after all that's not a state, we are not remembering in that, because we remember thing is here on the state, you know, here's when we remember the thing here. That makes a lot of sense. The TLDR of this, we'll now be able to append these things for that. Okay. So that was interesting, because now we were able to, when you have this particular selection pattern in the case of our UI, how it's important to think in terms of the when you have this UI selection patterns, it's important to look at how now you can remember state, how you can remember the states. And for this particular UI selection patterns, index or some sort of ID. Okay. So, for example, in the drag and drop, what you want to create is a Trello clone. That's great. You can have is not only your car, but also your column. And in the column, you're going to keep track as an array all of these cards here. Okay? Makes a lot of sense. And then you're going to append all of these elements here. All right? And this is just something that you're going to replicate across, let's say, 4 times, right? Good. So now, this is one phase. The other is that how you're going to do now to implement is a drag and drop functionality. So because here you're going to respond to several user inputs, in this case, it'll make sense to actually start to thinking about that, how helpful it is for us to use a reducer. Because not only we're going to handle is the on drag, which is what we're going to show when we pass these elements through a droppable area. So on drop sum, I think is another kind of event that is indicated that, hey, this actually is a droppable area where you can drop that. And there's some other events to manage is how you're going to, what will happen when you drag this element, when the user drag this element. So if I recall that, great, we have 3 states to manage. So here, now we're starting to make sense how useful it is to use is a reducer. Totally. Totally. How useful is to use a reducer. Totally. Okay. But again, this is for this particular specific business use case. Okay. All right. So now we look at here as passing data deeply with context. The TLDR of this is that most of the time we can pass data through our props. Okay, this is the way how you can pass data from parents to component. Okay, but when you have now grandchild components that you need to pass down data, if any of these elements in the if any of these React components for some reason is gone, so let's say you're not render that, you block that. So you break that change, and that's something that is quite hard to debug. So this is known as prop drilling, when you pass all of this data down to the relevant tile component that it needs to. So context say, all right, let's now have a place where we can store that data, okay? And those components who wants to make use of that data, they will notify to React to do that. And also we need to provide that data to that. So this is an alternative of passing to props. So the way of how you create this is by saying it's going to create a context that will hold our data or state, that will hold static data, okay, or an state, all right. And let me also use that context in the from the components that it needs to, like that. Okay, something that they mentioned here. Exactly. So let's go to create the context. Let's go now to use the context from the component that needs the data. Okay, from the component that needs the data, and then provide the context from the component that specified the data. So with this, when you create a context, React, it creates an object that doesn't hold any information. It only represents is which context all the components can read or provide. So this is the two properties that this context provide, which is the provider and the consumer. And in the provider, you must put that at the top of your component that is going to be used that data, all right? Use a particular hooks called use context that allow you to these components to read that data and make use of that. So what are the, we define here is the using and providing context from the same component. Using and providing context from the same components. All right. All right. Okay, cool. Cool. Yeah, using and providing context from the same component. So, so using and providing context from the same components. In context passed through intermediate components. Something that I looked at that yesterday, using and providing context from the same component. Like this. Like, oh, okay. Okay. Using and provide context from the same component. It's like, hey, I'm reading this data from the context, and then I'm going to provide that. Why, with this change, you don't need to pass the level props either to the section. Okay. This example uses levels because they show visually how nested component can override context, but context is useful for many use cases. You can pass down any information needed by the entire subtree, the current color themes, the current login user, and so on, which is one of the main cases of using context. So context passes through intermediate component. You can insert as many components as you like between the component that provide context and the one that use it. These include both built-in components like div and components you might build yourself. In this example, the same post component with a dash border is rendering at two different nesting levels. Notice that heading inside it gets its level automatically from the closed section. You didn't do anything. You didn't do anything special for this word. A section specifies the context for the tree inside. So you can insert a heading anywhere and you will have the correct size. Try it in the sandbox above. Because now this heading is responding to one of these, exactly, to one of these contexts. So now this component is responding to one of these contexts, okay? And that was a context that was provided at a pattern level, like so. At a pattern level. At a pattern level. Oh shit, sorry. Holy F. Lyme disease. Blast City. Postmates. The disconnect account. Send hi. Even Figma is using this. No, but this is a video, bro. Exactly. This is a video, bro. Multiplayer. That's quite interesting, bro. This is very, very interesting. How much is this shit, bro? Interesting. Holy shit. Latin doesn't work. Latin doesn't exist, man. Latin doesn't exist, bro. Latin doesn't exist. Very, very interesting. Very, very interesting. Completely. Because now with context, it allows you to, so now with context, allows your React components to adapt to its surroundings. And based on this particular example, to adapt to its surroundings, is like as long as you're providing its context to this, okay? As long as you're providing a context to this, to this subtree, now they're going to behave in this way. If you provide a context like this, now they're going to, oh, okay. So I want to now have the behavior, I want to set the behavior of this portion of the tree section, or this portion of the tree another section. And display themselves differently depending of where, in other words, in which context they are being rendered. This is what context allows. So context allows you to write components that adapt to its surroundings. That adapt to its surroundings and display themselves different, that adapt to its surroundings and display different depends on where they are being rendered. So depending on where they are being rendered, context allows you to show them different, or allow them to display differently. So it can be now for themes, it can be now for user interactions, it can be now for routing, okay, or for any specific knowledge, for any specific state for that. So now let me do this. Replace props drilling with context here. Exactly. Place image, place, list, and app. So our app here is now rendering is this list. This list image is say, okay, this is now our list component. Where now we're passing is the image size. Where now here it rendering is a place as a component, and this place component which contain is this, it has is this place image here, and this place image which is a component here now containing is the place image. As you can see, the render tree here is the entry point, the app, and then you have list, and then inside list you have is place, a list of places, okay, that's right, a list of places, okay, where now each of these list of places, how now render is a place, okay, and those place has is a place image as well. So now we got is a 1, 2, 3 levels here. So instead of doing that, okay, we are now not going to pass is the image size here, okay, and as a way to do that is we say, hey, let's go to create the context here, which is now is a cons image size here, which is this, but for that, because we are now responding is to this state, we would like to receive that data here. You know what I mean? By saying is with the name of the context. How do you call this context here usually? Let's say image context, right? So image context. You create your context using the create context object. You're going to put a 0 here. And here you import the create context, because after all it generate is a object from React. It generate is an object. Let me now export this. So it generate is now this image context is generate now is an object, say image context from context.js here, where now this image context it doesn't hold any information. It's just represent is which context all the components can read or provide to. In this case, the way how can we make use of this? First, we need to make use of this context in the component that we need to, which is in our case, I don't want to actually call this image here. In fact, I want to call this now, say, cons. By using that data, and how do we use that data? By in that component, we import is this hooks called is the use context. All right. In use context, need to pass the context object as a way to know which data that it needs to read or which context it needs to read. So we can say is image size here, okay. That'll be is, hey, I want you to now read the context from this image context. From the image context, okay, I want you to read this data from the image context here. Yes, I want to read this data from the image context. That's right. And I want you to now pass that data, image context. Image context. All right. So if we try to render this, I want to now use a fragment that allow me to render several elements here. Okay. Several sibling elements here, like P, and here actually be able to look at what image size is. So we actually are reading that data properly, okay, which is quite weird. Yep, to me it's quite weird. So okay, we're actually reading that data, even though that we are not passing down. You know, even though that we are not passing down that, but it's here, okay? Even though that we are not passing down, I'm going to put this initial value, okay? So now this actually works. We are actually reading the data. So I don't need any fragment here. as a way to look at what you're doing, what it's supposed to, which is great. But we fixed that. And in fact, we want us to now is to send the data properly, you know? So for that, here's what we're going to do is this. As a way to say, hey, I want now is to provide here is this data. Provide the context. So by looking at the image context, which is an object that it returned from that contains the provider and the consumer. Okay, the provider and the consumer here like so. And oh, because it's this is quite interesting. So this is how we actually get into this image context. This out exactly the image context is like this. Okay. So image context that provider here, it will return is the image provider the context React provider will create context exactly. And the value, okay, the value that it accepts this. Okay, so that's right. You would say, hey, what is the value that you want to pass to this? It's in fact is image size. Context image is undefined. Image context. Which is something that we put in here. The provider, exactly. So image content the provider with the image size. So we no longer need to pass this image size down there or here, not to mention here on the place or this. And in fact, we are now passing down that data to a distinct component, to a grandchild component called place image, which is this. It's a context that image is undefined because does not exist. It's in fact is this. And now this is how you can do this. There's some utility function here. Get image URL for that. Exactly. You're passing that image. You remove, of course, in all of the places that you need to, and then you read that for that. So image size, I want you to now read that data. Yeah, so far so good. It's like now that how components in the middle don't need to pass image size anymore. Exactly. And again, this is a pattern that is going to repeat itself over and over and over and over. But as you can see here, this now introduces the term, because after all, with the use context, okay, so anytime you actually read the data here with use context, The caveat is that React automatically re-renders all the children that use a particular context. So React automatically re-renders all the children that use a particular context from the provider that receive a different value. So if the provider receives a different value, all of those components that read, okay, all of those components that use that particular context will be re-rendering. So the previous and the next values are compared with the object.is. So that's what happened is here, that now you are getting all of these rendering issues here, because now it introduces this undeterministic behavior when that state changes. And with Reducer, once you have now this maintainable way to keep your state update logic, even though sometimes when you put this state, when the state updates in the wrong way, or when you update the value, when you update the provider's value, all of this context, all of those components that use context, automatically React re-renders it, meaning it calls those components, and all of this call that component and all of its nested component as well, and that can cause some performance issues if you're not careful. Skipping re-renderings with Mimo does not prevent the children reviewing fresh context from values. Skipping re-render with Mimo, because with Mimo allows you to skip re-renderings, so does not prevent the children receive fresh context values. If you build a system, if your build system produces duplicate models in the output, which can happen with Symlink, this can break context. Passing something via context only works if some context that you use provide context and some context that you use to read it are exactly the same objects. The context that you use to provide context and the context that you use to read it are exactly the same object, in memory. Passing data deeply into a tree. Okay, that's one of the trade-offs of this. Use context, always look for the closest provider above the component that calls it. It searches upwards and does not consider providers in the component from which you are calling using. Exactly. It searches upwards. It's a way of how now they look at the data. And the first that match, all right. Updating data passed via context. Theme context provider, like so. So updating value via context. Use theme context, use context in the panel and here. So you have a form, okay, where that form now have a panel and a button, and that panel use a context here as a way to show that class. So now this component is adapting to its surroundings by rendering is based on the context data, followed by the button here. What do you want? Use the dark mode. Oh, you'll have to use this, put the dark here. Okay. If you check this, now the theme will change to dark. Okay, this is now examples here. Updating an object via context. Exactly, you use a state here and the value as a way to pass is now the value here with the current user and the set user. And in your form, down deep in the login button, you're going to use that current user and read that data and then render something based on that. Set current user name at vcap. So here, this now component button here is now making use of its surrounding data as a way to show them something. When you click here, if the current user is different for null, which is something that we define here, it will say you log in as current username. Exactly, but in this case, you're logging as at Kiva. Oh, but because you changed the value there. But you start with null that context provider and the value. Who said that? Oh, here. You see how long did I have to take to do this? You see, you started to see. Okay, I received this data, but who actually stayed in that state? Oh, it's here. I find it quickly because it was just only one state updates. But what if you have multiple state updates? And what if this component is being used? And what is this what if there are several components that use the same context and only that data change for only specific amount of components? So context is something that is useful to use with primitive. With primitive. Or for tiny little small amount of data. For tiny little small amount of data. User, themes. You want to keep track the URL where you are. State updates, but for tiny little piece of data or state. Because otherwise it becomes a mess. It'll be harder to keep track of this. Multiple contexts. In this example, there are two independent contexts. Theme context provides the current theme, which is a string, while current user context hold the object representing the current object. So here you have two contexts, theme context and current context. You are both providing them here, all right? Exactly. And you have the dark mode on this mode. All right. So this is panel tile welcome here. Current user is different to null. Show the greeting or the login. So for example, if the current user here is null, you are now is rendering is this greeting or login form. Okay, here is the login form. So here in the login form, it say, hey, set current user. Look at how this called this current user, and we read this data from that, as well as these states that are relevant for this to visualize the different visual state here, and can log in first name dot equal to this. Label and a button that is going to set the state here, set current user for that. And then you got is this. And you log in as you gone. So after you set the state here, but the way you're going to set the state is now set last name and set the other is set the current user, which is here. Set current user. Use context expose you this. Set current user. Okay, now you can actually set the current user here. Set current user here. You are providing now here. Okay. Okay, because you're providing here is that current user and set user as a state. Okay, and here you say, okay, now it is time to set that. It makes sense. It makes sense. It makes sense. And use this context as a way for that, because when you do this, okay, now React will so those components that are reading this context, when that context change, React will re-render those components, aka React will call those components. So for example here, so when this context changed, those home components who are reading the context, React will re-render them, which is here. Oh my God. That's quite challenging. That's like what? That's like what? That's like what? All right. Okay, and scaling up without context and reducer. As a way to say text context, you're going to now have is your reducer here. You're going to pass this and add a task and the task list. But here they don't describe is the reducers functions. Task reducer. Yep, I can have access to the task reducer or the initial task. Task dispatch context. Okay, task dispatch context. So now they can have access to that. And on the task list, they can have access by using the task dispatch context. Use task dispatch. use task dispatch. Use task dispatch. I think they are actually returning is that task dispatch context. Okay. So that'll be all for this video. Take care. Bye bye.